1.4, Part 2, Composition of Functions. In Part 1, we did all of the normal arithmetic
Adding,
stuff.
subtracting.
Multiplying and dividing.
You may or may not remember.
But we did it in 1.4 Part 1.
Indeed.
And now 1.4 Part 2, Composition of Functions. This is like a new operation that only works with functions. And what it does is it lets us plug one function into another function.
Excuse me just 1 second. This is sort of important. Okay.
Okay. Glad we took care of that. So the way we represent the composition of functions operation is with an open circle. A closed dot would be multiplication, but an open looking dot is composition. And we look at it like this. It's
like you're looking at a fog.
Yeah, it is. It is like you're looking at a fog, and especially whenever I write it, it looks very much
Look, it's
like,
fog.
Look, it's fog of x.
This is not fog times x either. Like puppies, we want the puppies to live.
Yes, it's not fog times x. It's f of g of x, and that's what is written down here. Is how we would read this is f of g of x, or you could say f composed with g, or something like that.
Right.
Okay, or you could do it the other way around. But what's happening is basically anytime you see that open circle, you could put a parentheses like this, which is what is right here.
Right.
And that helps you see take g and plug it into f.
Well, everywhere there's a variable on the f function, you put whatever g equals into that thing.
Right. All right, let's give it a try. Let f of x equal x squared minus 1 and g of x equals square root of x.
Right.
Find the following composite functions and their domains.
Oh, which we already bring in restrictions.
Yeah, well, let's find it first, and then let's talk about the restrictions.
So I nominate a kind of a several-step issue for this as we're learning. So let's go with from fog to f of g of x.
So you want me to write it?
Right, yes.
Okay.
And then we're going to take out what the g of x and put what it really is in there.
Okay.
So now we're going to have f of square root x.
Right, because g of x equals square root of x.
Right, it says that.
Okay.
And then we're going to have what that actually is. So f is something squared minus 1.
And that something is now the square root of x.
That's it. That's it right there. That's how I recommend doing these till we get comfy.
Okay. Now, we'll simplify here in a second, but let's talk about the domain of each of these functions before we did anything with them. The domain of x squared minus 1, now you can get your calculator out and look at the domain, but...
It's not a fraction.
Or a square root.
So it's all reals.
Right. Okay, and then this one is a square root.
Oh.
So that means what values can we not plug in?
Negative.
Okay, so starting from 0
and including
up,
0.
Yes.
You can take the square root of 0.
Yeah.
Yep.
So what happens is we are, through this process, taking g and we're plugging it into f. Now this will simplify. Square root of x squared is?
X.
X. This
minus
simplifies to x minus 1, which is what f of g, I don't know if I have enough room to write it.
f of g of x is.
That's what this equals.
Now, if you're not mathematically astute, you would go, oh, that domain is all real numbers.
Okay, but it's not.
But it's a lie.
Because what numbers were we only allowed to plug in?
From 0 to infinity.
Okay, because we're taking g and plugging it into f, we have to use g's domain.
You can graph this too, and it will show you the correct graph, which might help.
If you graph...
but you have to graph it from this...
Before you simplify.
Yeah, you got to graph from that step.
And so this should look like... And actually it'll be misleading, right? Because it should look like a line.
Right.
But if you actually... Well, I guess it's a line, but it starts at 0.
Starts at 0, right.
It doesn't graph the whole line. I was going to say a hole, but that's not a hole.
No, it won't be a hole.
It
starts at 0 and goes. Okay, let's look at Goff.
Goff. Okay.
Bob Goff.
So,
famous motivational guy.
Rewrite it as g of f of x.
Right.
Okay.
And then g of x squared minus 1. That's what f of x is equal to.
Okay. And now, where x is...
Take that g function, take x out, put x squared minus 1 in.
Now wait, can we simplify this?
Yes, that's x minus 1. Everybody knows.
We're just yanking your chain.
Puppy dies if you do that.
No, that's not right. This is
we
as
all
simplified
like puppies.
As it can get. You cannot simplify.
Yeah, don't go any further. Remember, if you're going to simplify a square root, you have to have something squared. Now, x squared minus 1 factors to x plus 1, x minus 1.
And that's not the same.
Those aren't the same thing.
Yeah. You either have to have things being multiplied together, like this would simplify.
Right.
Okay.
You could even have...
Or you could have... Go ahead.
You could have x squared plus 2x plus 1.
Because that factors
to x plus 1 squared. But that's not what we have in this case.
Right. Okay, so be very careful not to get trapped by that whole thing.
Yeah, danger.
Now, what is the domain of the square root of x squared minus 1?
Well, we're already limited to, it has to be at least 0.
Are we? We're plugging in f values, and we're allowed to plug anything we want.
But you can't have a negative number in there, so you're limited.
Okay. So
because we have a radical situation.
Yes, yeah. So we need to say x squared minus 1 has to be greater than or equal to 0.
Right, yes, that's what I'm saying.
Okay.
Yes.
So if this does have a domain issue, which it does, we have to figure out what the domain issue is. But this one does not get a domain issue.
No, because he's already in real. Yeah.
Now this is tricky whenever you go to try and solve it this way. We know that x squared has to be greater than or equal to 1.
Oh boy.
What does that even mean? And so actually, let's think about this. Is a number bigger than 1 okay, right? Like I can plug in 2
right.
and I'm fine. Mm-hmm. But if I try to plug in a half,
nope,
I'm not fine. Okay.
You know, a good way to set this up is maybe to factor it.
Oh, maybe. And do x plus 1. And so what that tells us then is that 1 and negative 1 are our issue
Right, those
values.
Are the trouble points.
But what's happening for our domain is we can plug in anything from negative infinity to negative 1.
Right.
Because all those negatives are going to get changed to positives.
Remember, a negative times a negative is a positive, right.
But then it skips until you get to positive 1, comma, positive infinity.
Right.
So that's our domain for that.
There you go.
And these take some getting used to, but the key for the domain part is what did you plug in?
Right.
Okay?
Right.
If there's an issue where you plugged in,
then that's going to be an issue that's carried through.
Right.
You can graph these as well and have a look. But you have to graph from your original composition before you simplify.
Yeah. And so in this case, this one,
right.
like we weren't able to simplify it any further.
Right.
All right.
Good talk.